Okay, page 10 of lines. Let's see, C. Find the points of intersection of each pair of lines. So the first two lines are kind of weird lines. It's y equals 3 and x equals -7. So these are not diagonal lines. These are vertical and horizontal lines because the equations look so funny, right? So let's draw the graph of these. It's the easiest way. So let's see, I'm going to draw my axes like that. Let's see, this line, x equals -7, that means that the x goes through intersection point at 1, 2, 3, 4, 5, 6, 7, -7, so it's right there. What about the y? The y goes through y equals 3, which would be 1, 2, 3, there it is. Okay, so there's the intersection point right there. It's at y equals 3 and x equals -7. Wow, it's kind of a combination of those two, isn't it? Okay, so that's the intersection point. You can see that once you figure out how to find the intersections of vertical and horizontal lines, you don't need to draw the graph anymore. Okay, what about this next one? 1.5x plus 4 and y equals 1. Let's do that on the calculator. So we do y equals because we could just put this right in the calculator. It's in the right format. So we're going to put y equals 3 for the first line. Oh, I'm sorry, I'm looking at the wrong one. Y equals 1 for the first one. Y equals 1. 1. And the next one is 1.5x plus 4. 1.5x plus 4. Okay? So there's y equals 1. And 1.5x plus 4 is going to be a diagonal line. Okay, so we want this intersection point right here. The way we're going to find it is we do second calc intersect first curve, yes. Second curve, yes. Doesn't matter. There's only two curves in there, so. And it says, is your guess 0, 0, 4, whatever. It doesn't really matter what your guess is. You just hit enter anyway. And there it finds it, okay? The reason why guess is important is if you have more than one intersection point, you have to put your cursor near the intersection point you want to find. But if there's only one intersection point, then that's all you do. Negative, comma, 1. Negative 2, comma, 1. Okay? Moving on. E. So there's two lines here. But to put these in the calculator, we will need to solve for y on both. So let's see. For this one here, how about if we add x to both sides, and then we subtract 6 from both sides? So that'll get rid of those, and we'll have 2y equals x minus 6. And then we're going to divide both sides by 2. So we're going to get y equals x divided by 2 minus 6 divided by 2. 6 divided by 2, of course, is 3. Okay? What about this other one here? X plus y minus 3 equals 0. Here we're going to subtract x from both sides, and we're going to add 3 to both sides, and we'll get y equals negative x plus 3. So we have two equations. We have this one and this one, and then we just need to find the intersection. So we just enter them in the calculator. So one of them is going to be x divided by 2 minus 3, and the other one is going to be negative x plus 3. Negative x plus 3. Delete. Okay, graph. It's going to be two diagonal lines. To find the intersection, we're going to do second calc intersect. We can see it's going to cross right there, right? Okay, so we want to find that point. The way we find the point is we do second calc and we do intersect, which is option 5. And then the first curve is x divided by 2 minus 3. Second curve is negative x plus 3, and your guess can be anything because there's only one intersection on the whole screen, and the intersection is 4 comma negative 1. 4 comma negative 1. Okay, now the last one. The intersection between the y-axis and y equals 4. Let's just graph this one since it's vertical and horizontal lines. It's easier. Y equals 4 is going to be this line here, right? It crosses at y equals 4. And then the y-axis, the y-axis is here. So the intersection point would be right there. And so that point is 0, comma 4. 0, comma 4. Okay, moving on to number 3. Show that the lines L1 with equation negative 5x plus y plus 1 and L2 with equation 10x minus 2y plus 4 equals 0 are parallel. Well, parallel means that they have the same gradient. So how about if we solve for both of these so it gets in the form y equals mx plus b, mx plus c, and then we'll know what the gradient is for each one. So the first one is negative 5x plus y plus 1 equals 0, and we're going to add 5x to both sides, and then we're going to subtract 1 from both sides, and we're going to end up with y equals 5x minus 1. Okay, so that's that one. And the second one, which is 10x minus 2y plus 4 equals 0, let's see, we're going to put negative 2y on the left, and on the right side we're going to have negative 10x minus 4. And everything's negative, so let's make everything positive, multiply everything by negative 1. And then we're going to divide both sides by 2, so we're going to have y equals 5x plus 2. Okay, so here we have one equation. Here we have the second equation. Let's compare their gradients. And they're both 5, so that's why they're both parallel. Okay, number 4. State with reasons whether each pair of lines meet at only one point, infinite number of points, and no point. Okay, so normally, most of the time when you have two random lines, they're going to meet at one point because they're probably not parallel and they're going to run into each other at some point. So that would be the first case. The only time two lines are not going to run into each other is if they're parallel, and then they'll have no common points. If lines are collinear, which means they're right on top of each other, then they're going to meet at infinite number of points, and actually they are the same line. So let's look at each of these and we'll examine whether or not they're collinear, or if they're parallel, or if they are, just two skew lines which don't have the same slope. They're eventually going to run into each other. So what we're going to do is we're going to make sure that each of the lines is always in gradient intercept form, and if it's the same slope or not, then we can figure this out. Okay? All right. So this first one, we have y equals 3x, and then we're going to multiply 3 times each of the things in the middle, so we get 3x minus 15. And then the other one, we're going to have 1/3 y equals negative x minus 6. We're going to make everything positive instead. And then we're going to multiply everything by 3, so we're going to get y equals 3x plus 18. Okay, so now what do we have? We have 3x here, we have 3x here, so the gradient is the same. And then if we look at the y-intercept, one is negative 15 and the other is plus 18. So they are not the same line, but they have the same gradient, so they are parallel. So for this one, they are parallel, which means there are no points in common, so I'm going to say it's case 3. Okay? Next one. Oh wow, look at that one. That's kind of a mess. So we want to solve for y. So we're going to multiply both sides by x minus 2, and we'll get y plus 1 equals negative 1 times x minus 2. We multiplied the left side by x minus 2. We got rid of the denominator. We multiplied the right side by x minus 2 also. Then we're going to multiply this negative 1 to both of those, so we get negative 1x plus 2 equals y, and then we're going to subtract 1 from both sides, so we'll get subtract 1 there. So that'll give us negative 1x or negative x, and it's plus 2 minus 1. So plus 2 minus 1 is just going to give you plus 1. Okay, and then the other equation they gave us is y equals negative x plus 1. And what do you know? It's the same equation. So that is the same as that. It's exactly the same. So that means that the lines are on top of each other. So they meet at an infinite number of points. Okay, next one. Y equals 4x minus 8 and 4x minus 2y equals 0. So let's convert this one to gradient intercept forms. You have negative 2y equals negative 4x. Multiply both sides by negative 1, so you get 2y equals 4x. Divide both sides by 2, and you get y equals 2x. So let's compare the gradients. 2 for this one, and 4 for that one. Nope, different gradients, so they must meet at one point. So that's the case of number 1. Last one for this section. X minus y plus 3 equals 0, and 3x minus 3y plus 9 equals 0. So the first one is y equals x plus 3. I'm going to solve for y on the left side. And this one, let's see, what if we divided everything by 3 to start out with? Well, I don't want to confuse you. So let's just put negative 3y on one side, and then we'll put negative 3x plus, minus 9 on the other side. Okay, now let's divide everything by negative 3. And then we'll have y equals x plus 3. So we have y equals x plus 3 here. We have y equals x plus 3 here. It's the same line, so that means they meet at an infinite number of points for this one too. Okay, last one for the problem set. Line L1 has gradient 5 and intersects line L2 at the point 1, 0. Find the equation of L1. Find L2 that is perpendicular to L1. Okay. So L1 has gradient 5 and intersects L2 at the point 1, 0. So we know that L1 has gradient of 5 and it goes through the point 1, 0. So let's see, there's a couple ways we could do this. One is we could graph it and we'll find one more point and then we'll use linreg. And the other way is algebra. Okay, so let's do linreg. I'm going to draw there, okay? So at 1, 0, 1, 0 is right. 1, 0 is right there. Okay? So the line is going to go through that point. What's the slope of the line? It's rise 5 over run 1. So I'm going to draw this triangle here. 1, 2, 3, 4, 5. Okay, so it's right there. 5 divided by 1. Okay, and okay. So what is the equation of this line? Well, we already have one point. It's 1, 0. Let's find a second point. Well, we just found a second point by constructing this triangle that's 5 high and 1 across. We know that there's a second point at 2, 1, 2, 3, 4, 5. At 2, 5. Okay. Now we can put both of these points into the calculator into stat edit. And when we do that, we can run linreg on it. And we can find a line that goes perfectly through these 2 points. Two, 0, 5. 1, 0, 2, 5. And then we're going to do stat calc linreg. L1, L2, that's where we put them, so we just leave L1 and L2, and we do calculate, and then it gives us the equation y equals 5x minus 5. So this blue line, the equation is y equals 5x minus 5. The next one, the line L2 is perpendicular to L1. Okay, so for L2, the slope is equal to the negative inverse of the original slope. So this new slope is going to be negative 1/5, okay, because it's perpendicular to the slope m equals 5. And now we're going to find the equation of L2, which goes through the exact same point. Okay, so one of the points for L2 is 1 comma 0. Okay, and now we're going to let's do this one with algebra just to vary things a little bit. So we have one point that we know, which is 1 comma 0. And we know that the equation for the line is y equals m, which is negative 1/5, x plus c. We don't know what c is. But we do know that one point on the line is x equals 1, y equals 0. So what if we put 0 here and we put 1 here, and then we're going to have 0 equals negative 1/5 plus c. So c is equal to, if we add 1/5 to both sides, c equals equal to 1/5. So actually, the equation for L2 is y equals negative 1/5 x plus 1/5. Okay? All right. That's it for this problem set.